So good morning, everyone. Thanks for coming. So the scope of the talk is going to be the core, basically the core data and metadata services of Carbon Portal. Carbon Portal is bigger than that, but so the scope is just that. Well, from the beginning, I want to mention this is the link for the presentation. It is online. You can watch it even from your phone. So I will not waste your time on introducing ICOS. I assume you know what it is. So Carbon Portal may need a little bit of introduction, but we could say the primary mission statement can be popularly summarized as a one-stop shop for ICOS data, pretty much. As I said, there are more missions, but the data and metadata it probably can be summarized like that. So we're hosted by Lund University in Sweden, the Department of Physical Geography and Ecosystem Science. So from the beginning, we had a list. Well, basically, by 2015 was when I started. When we started, you could say the active implementation phase of the services, but the start itself was of the Carbon Portal, and the planning stage was before that, probably like 5 years earlier. So by the time we started implementation, there was already a number of requirements that were listed and talked about, and they're presented here. It's a bit, it's a lot of text, but I would say that all of them are important. So, well, so one thing was this temperature-resistant traceability, the notion that, well, we should be able to show that the climate models, they have not been produced with fake data. That's probably the short version of it. Then, of course, we need to preserve the data for a long time. Then there was this concept of online data shop, similar to the online shopping. So the way you can search for data, preview, and then add it to something like a shopping cart and download. Then all the data objects or files, they must be citable, and producers must be acknowledged. And it is very important for producers. And I guess some of the people listening to this are producers as well. So let me assure you that we're putting a lot of effort in giving the attribution to the producers. Then the downloads and citations should be counted. And then well, actually, I shouldn't say the web services in general, the services should be machine usable, not only human usable. And then there was the important point was about single sign-on. So by 2016, already many of the design decisions have been settled down. There's a lot to unpack here, and we will not go through all of it. This is more for reference. So I have highlighted the things that are probably most interesting. Well, then, yeah, the APIs are built on HTTP. That's a little bit, well, it's kind of an obvious choice, you could say. So simple HTTP, let's say, nothing fancier than that. And then for the data object themselves, I guess mostly inspired by this tamper-proof requirement was the decision that we want the data objects to be immutable, and the identifiers, they were designed to be based on the content of the data object. More on that later. But the idea is that, well, the identifier of the data object, the name of it, the technical name, you could say, is already has integrity control baked in. That's, I think, enough for this. Let's not go into technical details too much, at least not yet. And well, I guess we could say that, well, we are pretty old by now as a project. It will be the active development phase, the code base, let us say, put it like this, the code base will turn 8 years old in February. So quite old. And as you can imagine, there's a lot has been done. There is a lot of services in production. So there is not, it's not a complete list. So yes, of course, we offer the possibility to upload data, then we host data, then we allow to search data, visualize and preview. And of course, we have a metadata database for the metadata about these files. Then we, of course, we provide some API for querying the metadata, and then we offer the service of minting PIDs and DOIs. Well, I guess everybody knows what a DOI is. So what articles, or every scientific article gets. PID is, you could say, a lightweight version of that. And then we also, it's a bit outside of the scope, but we host the Jupyter and Notebooks server that provides direct ICOS data access and allows for experimentation. And then a variety of other services, some in-house built, some third-party. And then also what I think is interesting to mention for this talk is that ICOS is not our only customer, if I may say so. So we also have another research infrastructure whom we serve in parallel. So all our core services, they actually repurposed, and well, they at the same time as they serve in ICOS, they also serve infrastructure, Swedish national infrastructure called Cities. Why it is relevant? Well, because maybe this is how we can treat ICOS Cities project. Maybe as one of the options is maybe we can treat it as a new research infrastructure. Then we will have 3 customers. As well, it's an option to go forward. Okay, so now the foundation of foundations. So the data object definition. What is the data object for us? Well, the data object is just a sequence of bytes. That's all. That's what it is. And we identify it using this industry standard cryptographic hash sum called SAH256. Which is 32 bytes in total, and it can be represented in different ways. Like this is a hex. Well, it's just 32 bytes, or you can encode them in hex or base 64, or there is this other encoding called base 64 URL, where you replace non-URL friendly characters plus and slash with something else, minus and underscore. And then, well, what we do, we say that, well, this is a bit too long and we don't need so much. So we take only the first 24 characters of this, and that is equivalent to 18 bytes. And we call this, this is our ID. This is what we use as an ID for this sequence of bytes in the data object. And well, just so that we can all sleep well during the night, well, I did the math. And to go to the collision probability to 50%, you need to have this many hashes. That's what is it, like 5,000 billions of billions, something like that. So that's way more than we're going to have. So I think we're quite safe with collisions. But well, okay, so that's what the data object is. So as you can imagine, this is not super useful. So if you have a binary blob and you know its hash sum, well, there's not much you can do. So it's all, of course, the game is, the name of the game is metadata, of course. It's the most important thing there is. So of course, I mean, you don't want to lose the data, but if you don't have metadata, then there's not much you can use it for. So, well, what sorts of metadata do we have? Well, quite a lot, but as an overview, it would be the stations that produce the data, the people that were involved in the work, the roles that the people had, the instruments that were used, and some other details about data objects and also about their provenance. Provenance, that's basically what was happening to them. How did they become like they are? That's what provenance means. Then, so a couple of choices or principles for our metadata. So we chose to use the so-called linked data or semantic web or RDF. There are many names to this, but this is the technology stack or the public metadata publication practices or standards, if you like, that we have chosen to use for our metadata. Well, I will give a little intro to this, but we will not be focusing on what it is, just the basic principles a little bit later. So a bit more details on how our metadata is designed. Well, okay, so first, of course, there are the basics of information about the data object, regardless of where it comes from of the nature of it. So typically, you want to have a file name. People think in files, and they want to have a file name for a data object, and usually it's useful. And then, well, size in bytes is one. Also such a basic characteristic that will be relevant for any, regardless of the nature of the data object. Then provenance that was mentioned before. So, well, design of it is of this metadata model is inspired by so-called prov O ontology, which is a standard. So we kind of pretty much follow the design and even reuse the concept or inherit from them. So it looks like this. So there are three kinds. We recognize three kinds. So this is this is something called activity, I think, if I remember right. And then we recognize three types of them: acquisition, production, and submission. And this is something that data object is associated with. So data object has been subject of an activity or was involved in an activity or whatever you prefer to think. Yeah, actually, I don't remember the name of the property here. And then the activity itself, it has a start time and end time, and then it is associated with something they call agent, but more specifically it's person or an organization. So yeah, and then of course these objects, they can contain some extra properties as well. For example, for acquisition, for us, yes, this association will. So organization, well, an example of organization could be a measurement station. But then you could, so you attach measurement station to acquisition. That is, the data object is coupled to a station indirectly in 2 steps. But then acquisition can contain other things, like, for example, it have a coupling to instrument or sampling height, for example, for atmospheric data. Well, then production could. Yeah, and then of course they could have some. All of them could have some extra information naturally. Then the person. I can't see my screen. Sorry, give me a second. I will try to hide the panel. There. So then the other aspect of metadata is that metadata about people, organizations, and the roles that people hold. And here we have a design pattern that looks like this. So we have, so there are different types of organizations. So these nested boxes, they symbolize subclassing or subtyping. So we have so station is a kind of organization, and then a central facility is a kind of organization, and that could be a calibration lab or carbon portal or thematical center. We have 3 in ICOS, as you probably know. And then, so the design pattern is that person is not attached to a role right away or to an organization right away, but there is an intermediate hub. We call it membership, and it is like an umbrella entity that combines the couplings to organization, the type of role, and the time. Because people, when they assume a role, normally is time limited. They start at some point and they end at some point. And then the role, they have a certain role at a certain organization for a certain period of time. This is a pretty flexible design because then a person can have multiple roles at the same organization and at different organizations and so on and so on. And multiple people can have the same role. They can overlap in time partly or fully and so on. So full flexibility here. Then the third aspect I'm going to mention is the, well, we call it internally data object specification. For the users, we call it a data type. It's probably easier or more popular notion. It concerns the actual content inside of the data object. Typically, if it is a time series, a columnar, basically a single table time series, then we want very much to be able to tell the users about the variables which this time series has and what these variables mean. And because sometimes the variable is can be very cryptic. So when the CSV files that come to us, sometimes the variable names that come from the data producer, they're very cryptic for laymen. They probably, and not even for laymen, I think even for people in the field, but who don't work at that station or in that particular community, the variable names can be cryptic. So that's why we provide extra metadata. So yes, we do keep the, so basically, okay, let me just explain a bit. So we start from a data object here, and then we attach this data type or data object specification to every single data object. It's a must, the property must be there. And then for those who we know something about the structure, then we have a so-called dataset specification, which is a collection of the dataset columns or dataset variables, depending on the kind. It could be a single table like a CSV time series, it could be netcdf files. So we have a list of variables, and then these variables, they have something we call value type, which is supposed to be well explained and well defined notion from the field, from the domain, from the knowledge domain. And then of course we also keep the original variable name we retain as well. And then other things that this data object specification contains is that it couples to certain useful classification parameters. So there is, like, for example, ICOS has the notion of a data level to show if it's raw data or automatically processed or full quality, or is it an elaborated product. So we have 0 to 3. And then there is a notion of a theme, atmospheric, ocean, or ecosystem, or a notion of a project, and so on. And there is also association with keywords, which can be attached either to the specification or to the data object itself. Well, yeah, that's the three aspects. It's not full detail, but full detail would take too much time. So I will just mention that, well, to implement these the metadata models, as I said, we use this RDF data model. It is called. It is a pretty well-established standard from World Wide Web Consortium. The key ideas are very simple, actually. So everything gets a URI. So all the notions are represented with some real URI or a real URL in our case. So you can so there is a URL for a station, URL for a person, URL for an instrument, for a data object, and so on and so on. And you can visit those URLs, in fact. And so they are stored. So they are used as IDs for metadata entities inside of the database. But also they happen to be the referenceable URI. So you can visit them and get some page and get some information about this there. And then the other, so that's the key idea number one. And then the key idea number two is that RDF is just a collection of super simple statements. They're called triples. And they have they're triples because they consist of three parts: subject, predicate, object. And this, so this could be data object has size in bytes, 1000 bytes or 1000, or a data object has file name and then a string here, or it could be that was when the object is literal, or it could be, as we were talking before, like in like here, a person has a membership. That could be another example of such a relation. So from these triples, it's basically links between boxes. You can think of every RDF statement is a link between boxes. This is also a link from a box to a literal and so on. So it is a very simple and very flexible. And well, you can query it. It's very generic. Okay, so well, like a little demo. So what do we achieve with these metadata models? Well, first thing, so one fundamental service is that every data object gets a landing page where you can read about it. And as you can see, you can see directly from the format of the link. It's well, it's our domain name, then objects, and then comes the object ID. That's how we. That's how the object's identified. So that's where the landing page is. So, and then if you click on it, you naturally you get the page. And well, if you inspect it, you will find that it is swarming with metadata. We don't have time to go through all of this. There's just too much to talk about. We could have probably by now, we could have a presentation just about the landing page and what it contains. I mean, if you have questions, ask them, we can maybe discuss, but yeah, so, and then again, so all the things here, you can click, like the object belongs to a collection. It has a URL, you can click, you visit the collection. And so on and so on. It has a data type, you can visit that. It has a license, you can click on the license and you read the license. It has a metadata, can be represented in different formats. It can be JSON or different serializations of RDF or an ISO compliant XML. There's a link to instruments. Well, they have the same name, but they are different. And you click on an instrument, you read the serial number of it, and the vendor, and who is the owner, and so on. Then, of course, all these times, start and stop time, then the content, the previewable variables, which you can click and preview right away, already from here, from the landing page. And then you can also download this individual file by one click, or you can add it to your data card if you want to have download many at once. That's that's the most basic service, and a little bit more advanced service. That's our flagship product. We call it the portal, but it's basically search app, a search app for the data. It looks like this. It could be a bit overwhelming for first-time users. But well, if you don't have experience with it, I'll just suggest take a little bit of a time and then spend well, click on the, just click around. There are these question marks which you can click and read about. And well, the idea of it is that, well, so all this rich metadata, it allows us a so-called multifaceted search, where you can start drilling down the amount from different aspects. So here, well, by default, when you visit the page, we limit it to ICOS high quality data, or level 2 or 1, I think, and 3, maybe, I don't remember. But if you clear all the filters, then you will see more, raw data included. Actually, if you go into advanced and even show so-called deprecated objects, you will see that we're approaching 1 million here. But in fact, there are many objects which are hidden by configuration. So we're well past 1 million data objects by now, probably 1,200,000 or something. And we still managed to have pretty good performance despite that. And well, you can start filtering from many different aspects. Like, for example, you could maybe interested in data from a certain station. So you can type name of a station, Hiltemosa, and then you get, these are two because one is ecosystem, one is atmospheric. Or maybe you can be interested in something different. You may be interested in certain measurements. So you can type temperature, and then you see all the kinds of temperature that we have available. 3 temperature. How about that? And then, of course, many other filters by time, by submission time, by file size. You can even paste in a file name and find the exact data object you want, or you can paste an ID or a PID. I didn't mention the PID. PID looks like this, and the DOI is a special kind of PID. It looks like this. Well, format is the same. All right, well, we don't have time for much more detail than this, I think. Well, how is this enabled? Well, what kind of software we have to run to enable this? Well, we have 2 main services to support what you have just seen. So the landing pages, for landing pages, you only need this, the metadata server. Well, again, I don't think we're going to discuss this in detail. This is just to show that, well, we have 2 big software components, and well, they have a certain structure which you can look up, and yeah, whenever you need to use this, you can use this as a reference for just a general overview of what how they are structured and what they offer. Then one important collaboration activity within ICOS Cities that we anticipate is data upload. So here is a diagram showing how the data upload happens. And there's many steps, as you can see, but most of them are performed for you by our machinery. So the uploader needs to do only 2 steps. Step number 1 here, and well, step number 2 is the result of step number 1. It's just a response you get. You submit a metadata package to the meta service, and then after that you've been told where to upload the data, and then you upload the data. That's the 2 steps that need to be done, and well, we have a documentation for this. Well, there is also step 0, authentication, of course. And we will need to provide the authorize U2, that is done by us manually. Well, anyway, so this is, well, it's described pretty much in detail. So it's pretty well described. There's no need to go through it right now, I think, just a collection of links for the future use. And another thing, as well as I mentioned, metadata is the key. And so the story of metadata at ICOS, it is pretty complicated. So this slide is not for you to understand fully, of course. I mean, it's just to show you that, well, it's complicated. It works more or less. I think we're not too unhappy with what we got in the end. So we have a lot of flexibility, but the complication is that, well, we have 3 thematic centers, and they prefer to be the owners of the metadata. So they want to be the source of truth for their own parts of the for their own parts of the metadata. And we have to collect it from them. And of course, they store it in completely different formats, and they want to deliver it in 3 different ways. And then we need to reconcile it and deduplicate and curate sometimes. So, for example, sometimes they have the same person. There could be a station which is at the same time atmospheric and ecosystem, and there could be a person that is a PI at both. And then, well, we don't want to have 2 persons which are called the same. So we need to deduplicate things. So problems like that. And then, of course, the renamings. or misspellings of names, or changing of names, or changing of email addresses, and all of that. So there's many things that we need to keep track of and not break things. Yeah, it's hard. And therefore, well, what we can think about is that, but that's not the only option. That's the thing. There is an alternative approach when we host the metadata centrally, and that is what we are doing actually for this other customer of ours that I mentioned, sites infrastructure. The way it's done is like this. We have a piece of software which was written very early on, and we still use it. We call it a generic metadata editing interface. They all look well, and then we use it in many different contexts. For example, it looks pretty bare bones. I can show you quickly. So when the head office needs to enter the candidate stations, they use it. It looks like this. They come in, they edit it. It's pretty basic, but you can use it. Why we have it? Well, it's because what does it mean, generic? Well, generic, it means that you can repurpose it for many different metadata models. There's provisional stations is one type of metadata. Then we have our own Carbon Portal metadata, which has a different metadata model. And this is, by the way, where we define our value types and variable names and so on. And some of these memberships and ecosystem types, some variables as they come to us, and so on, you name it, we define it there. And that's why the preparatory work for data upload is done, by the way, when we need to predefine the metadata for what is gonna come in. And then we have the Ocean Thematic Center has actually chosen to host their metadata with us. Well, we cannot let them edit the final ICOS metadata, so they use this interface for editing their own version, their own picture of the world as they see. So we designed and we created a metadata model just for them, and then we use the generic interface so that they edit the picture of the metadata as they see it, and then we do our best to try and reconcile it with the rest of ICOS, so that we have a uniform view of the stations, instruments, people, and organizations, and so on. And then when all of this is taken into account and put together, then finally we get a production ICOS metadata. This is a picture where everything is put together, and this is like the final production version of it. We're not supposed to edit it. It is just for viewing. So that's a pretty complicated picture where we are with ICOS, and the sites they have made a completely different choice. Well, they're smaller, and was it possible to reach? Basically, they were happy about the solution where all the metadata that is needed, basically the production sites metadata, well, you see it's styled a bit differently. So the instruments, the ecosystem types, and all these data set columns and so on, these projects and you name it, all of these production things, they are edited directly in place through this interface. And then there is no need for this complicated interfacing between the thematic centers, all this logic for reconciling, and so on, so on. So that's basically an alternative approach. And I think now that we are kind of early in this collaboration, I think this could be an option to discuss and consider. That is, I think it's mostly it. I will mention that I made a few other slides, which are, you could say, more details, but these are basically reference information. This is a technical, this is mostly of interest for actually internally for us developers, the so-called communication diagram. This is every single piece of software we use in our core services and how they communicate with each other and the web browsers of the users and so on and so on. Of course, no need to go into details on this. This is for the technically savvy who are curious what tools we use and what software and the programming languages and so on. And this is just a few extra links. That is all I have, I think. I think we now can use the rest of the time for questions and discussions.
Thank you very much, Oleg. This was a very good insight in our workings of the Carbon Portal and how it has evolved. Thank you. So far, there is no question in the chat box. And at the moment, I do not see anybody raising their hand. So if you have a question, please just, oh, there is somebody. Christoph, please go ahead.
Yes, hello, and thank you for this very nice presentation. I'm kind of hesitant entering my question in the chat because I find we're not a big group and I think it works better that way, if that's okay. Good. Yeah, very nice to see all that infrastructure in the Carbon Portal having been put together over the past years. I have a very specific question, and that relates to the additional customers. I saw that the Sites project uses your services, and that is, as I understand, the national greenhouse gas monitoring system, kind of a national initiative. Is that correct? Yes.
I think it's more. I think they are mostly ecosystem. I'm not even sure how. Okay. Yeah, it's mostly ecosystem measurements, I think.
Okay, but my question is actually, would it make sense? Just to give a bit of background, we just had a kickoff meeting of the integrated greenhouse gas monitoring system for Germany. That's a joint project with the German Weather Service, with University of Bremen in remote sensing, with University of Heidelberg, with Jena here. So that is utilizing ICOS data, but also producing additional data that might go into ICOS data sets at some point. So basically augmenting the network on the national scale. And we've been discussing this, whether it would make sense to actually use the services of the ICOS Carbon Portal, because whatever additional data we will generate within that project might be useful for others, because the atmosphere doesn't stop at the border, and process knowledge also not. And so it might be better than for every nation, for every national project to come up with their own data infrastructure. What is the position of the ICOS Carbon Portal in that aspect?
Well, it sounds pretty political to me. I would not be the person to answer. And so my answer to these things is usually that we are already overwhelmed with what we have to do. So ICOS Cities, I mean, if you don't give us any extra work to do, we can be busy for the rest of our working careers, just maintaining this and keeping this what we have in good shape and updating the machinery and improving the robustness. and implementing what is left to do that we have in the pipeline, this all together will probably keep us busy, keep us employed for the rest of the time. But if you ask Alex, who is our director at Carbon Portal, then probably you would hear something more optimistic and welcoming.
Yeah, I see that as more like a political decision or question. Maybe also a question of funding, coordinated funding to, augment the services there, because it's additional services and means additional work, obviously.
We could thing is that we have typically 3 different options to tackle this. When we have extra customer, let's say, then we have 3 options. So we have wait, sorry, give me a second. I need to do I find the yes. So one option is to create a new project. So here we have a list of projects. Some of them, for example, SOCAT was done just for historical purposes because we wanted to have something early. And or INGOS, for example, that's historic data, or European OPSPEC also, you could say this is like historical side project. So one can, if there is an extra data, which we are very generic. So we can accommodate so any environmental research infrastructure data. I think we could accommodate pretty easily because we don't even it doesn't even have to be environment as long as we the developers are concerned. It's all abstracted away. But one option is to create a new project and then define a number of data types and then give people the permission and then allow submission, or they will give data to us, we would upload. There's quite a bit of data which is not ICOS. So you can see that ICOS is only one project of several here. So that is one option. Another option is to create, which we always discuss in such cases when this pops up like ICOS Cities is was the same dilemma, and we still haven't decided finally. The other option is to add this as a third ENVRI. So we have this notion of ENVRI on one, and we have 2, ICOS and sites. And we could add the third ICOS Cities, or we could add third national German infrastructure or whatever, and then serve them together. Or yet another option is to actually deploy, so actually do this and then also deploy a separate instance of the services, so that the ICOS Cities data live physically on a different on a different server. Could be on a different server. That's so these are, so from the technical viewpoint, these are the 3 options we can offer, like a new project and new data types, and then it looks like it comes from ICOS data portal, new ENVRI, or new ENVRI and a new instance which is hosted maybe even elsewhere. And they have different cost.
To butt in, I cannot raise my hand because I'm the host of the meeting. Sorry, Oleg. What of those 3 options? Obviously, I am very interested in ICOS Cities. Well, which version would you think is a good one for ICOS Cities to move forward? And then I have 2 additional questions to that.
Well, if I knew that, then we would probably already have a decision. We were discussing it a few times with Alex, and somehow, well, I'm not sure. There's different costs involved and different things to consider. For example, if it's a different ENVRI, then it would need a different domain name. So the data object, they would have a different prefix. And then if you have a different ENVRI but the same server, then you cannot host the same data object in 2 ENVRIs. Right now, our software does not permit that. So the internal, we call it magic indexing, it only uses this hash sum. So it doesn't care what env it is, it uses hash_sum to identify the object. So if you just by chance want to host exactly the same, like binarily identical object in one env and in the other, that will not be possible unless you split into a different instance. So that's one technical limitation that we have, but then it's a cost, of course. So to add a project and then a new data types and then start uploading into ICOS data portal is the cheapest approach.
And that would be the faster way probably as well, because well, ICOS Cities is already producing data, which cannot be uploaded at the moment. So okay, good. Thank you.
Yeah, the cheapest is this, but then is this what we want? Is another question, and also like because we could say that, well, maybe do we, because ICOS Cities, I understand that the diversity of the data will be quite big. So then the risk is that we will drown the original ICOS data in it, but is that maybe that is not a problem. So it's many like semi-political decisions. So it's like it's a problem with multiple aspects. So there are technical limitations, but then there could also be like user experience or even political considerations, and they all have to come together at some point. We haven't spent enough time talking and thinking about it simply, so we don't have a decision.
Yeah, we will certainly discuss this also with Alex in the future. That was an idea that popped up in the last weeks during the kickoff meeting. And I just wanted to take that opportunity to chat about that. And yeah, thank you. That's cool.
Is there anybody else with a question? Then please just jump in. Otherwise, I will have another one. As you mentioned, Oleg, we will most likely have rather different data in ICOS Cities, well, additional different data to what is in ICOS right now. And especially the part of unstructured data. So we will have, well, one partner is the European Social Survey, and they do conduct interviews. So I'm not sure in what kind of format this data has to be stored, but I guess it will be like more unstructured blob-like thingies. How can we deal with that if we, have this framework of the Carbon Portal software?
Well, the unstructured blobs are the easiest to support. The problem with them is not, dealing with them is not the problem, they actually is the easiest, because the preparations for the upload are simplest. You just need to design and like add a new data type using this generic metadata editing interface. And yeah, there's just to fill in a few things, and then yeah, you give you configure user permission, and then they start uploading. And there is no, the disadvantage of it is that there is no validation. There is no information about what the file contains. There is no search by variable name or column name and such. So you can only use this. So in the search, in this one, so this data origin part will work. Sampling height will not be there. No, it might. Sampling height might, if the uploader happens to associate, but that is a small detail. Data types, this part will work for unstructured data, but then this part, this value type, variable name, unit of measurement, quantity, kind, it will not work. Then sampling date, it will, because the uploader, if it is experimental data, will be obliged to provide the temporal coverage. Submission date filtering will work, file size filtering will work, of course. So what we lose is the one is the ability to search and filter by the value types, and of course preview the data. To preview the data, you have to have variable metadata for it. And of course, we need to have support for that format. And right now, it's only the single tabular time series and the spatio-temporal netcdf files. And then we plan to add support for time series netcdf2 relatively soon. That will be the third kind that we offer previews of. That's how we deal with unstructured data. No previews, no variable information, but the preparation for uploads are actually cheaper.